In the early years of World War II, the Messerschmitt Bf 109 dominated the skies as the Luftwaffe's most successful and prolific fighter aircraft. Its agility, power, and versatility made it a formidable opponent across multiple theaters of war. However, by 1941, with enemy aircraft improving in speed, armor, and armament, German engineers began to realize that the Bf 109, despite its many upgrades, was reaching the limits of its development potential. The call for a next-generation fighter to replace the aging design became urgent. It was in this environment that the Messerschmitt Me 309 was born. The Me 309 was envisioned not merely as a replacement, but as a leap forward a new generation. A fighter with cutting-edge aerodynamics, improved landing gear, increased firepower, and better pilot ergonomics. But despite its promise and innovation, the Me 309 would become one of the Luftwaffe's many projects that never reached operational maturity. The story of the Me 309 begins in 1940, just as the Luftwaffe was enjoying its dominance during the Battle of France and preparing for the fateful Battle of Britain. Even with success, concerns were already growing among Luftwaffe command and engineers. The pace of aviation advancement meant that what was modern in 1939 could be obsolete by 1942. Germany's adversaries, particularly Britain and the United States, were rapidly developing advanced fighters like the Supermarine Spitfire NKV and the Republic P-47 Thunderbolt. In response, the Reichsluftfahrtdienst RLM, the German Air Ministry, began to solicit proposals for the next generation of fighter aircraft. Messerschmitt responded with a bold plan. Rather than just upgrading the Bf 109 once more, Messerschmitt proposed an entirely new airframe in secret discussions and internal development. This new aircraft was designated Project 1099, but quickly became known as the Me 309. The project gained traction in 1941 and was officially approved for development. The concept was to leap past current fighter designs and introduce something both evolutionary and revolutionary. The Me 309 would feature several design departures from its predecessor, including a tricycle landing gear, a major innovation compared to the tail-dragging undercarriage of the Bf 109. This design promised better ground handling and visibility for the pilot during takeoff and landing, a known weakness of the earlier aircraft. Another revolutionary feature was the pressurized cockpit, aimed at enhancing pilot comfort and combat readiness at high altitudes. The fuselage was streamlined, with a more spacious and ergonomic cockpit. The wings were of new design and promised better lift and control at various speeds. The aircraft was to be powered by the Daimler-Benz DB603 or DB605 engine, offering greater horsepower than earlier models. On paper, the Me 309 was everything the Luftwaffe needed. As the development progressed, the RLM pushed hard for rapid results. With the war intensifying on the Eastern Front and Allied bombing campaigns gaining momentum, time was of the essence. The Messerschmitt team, already stretched across numerous projects including the Me-160 to jet fighter and ongoing Bf 109 upgrades, was under immense pressure. Yet despite the strain, the Me 309 prototype began to take shape. Its structure was a mix of proven techniques and new ideas. Engineers aimed for high performance, but also reliability and ease of production. Emphasis was placed on speed and climb rate, critical factors in air superiority. Armament options included a pair of MG-130-1 machine guns in the upper nose cowling and two MG-151 cannons in the wings, an effective mix against enemy fighters and bombers. The first prototype, Me 309 V1, was completed in mid-19 for Dada in the fall of that year. The aircraft was ready for its maiden flight. Expectations were high, and engineers hoped to finally see the next step in fighter evolution. However, what occurred during the early test flights was both disappointing and alarming. From the very first flights, the Me 309 displayed problems. Although it took off successfully, its flight characteristics were now significantly better than the latest Bf 109 variants. The aircraft suffered from stability issues, and the new landing gear, while innovative, had reliability problems and added mechanical complexity. The nosewheel design, which gave better ground control, proved to be more fragile than expected. Even worse, the Me 309 was not faster than the Bf 109G, which had continued evolving during the same time. In fact, in certain tests, the older aircraft outperformed the new design in key areas. This posed a major problem. Why invest time, resources, and energy into producing a brand new aircraft that offered no clear advantage over an existing and combat-proven design. The Luftwaffe Command and our LM officials began to grow skeptical. While the engineers believed the Me 309 had potential if given more time for refinement, Germany's wartime situation did not allow for long development cycles. The Allied bombing campaign had already started to pressure the industrial base, and every project had to prove its value quickly. Compounding the issue was the emergence of jet propulsion. By 1943, the Me-162 was becoming the center of attention, the promise of an aircraft that could fly faster than any Allied design by a wide margin made traditional piston-engine fighters seem like a thing of the past. Though the Me-309 was promising in its own right, it suddenly seemed outdated before it even entered service. Messerschmitt tried to salvage the project by proposing several modifications, including changes to the cooling system, tail design, and armament configuration. These adjustments improved handling slightly, but not enough to justify production. By early 1943, the writing was on the wall. The Me-309 had become a dead-end project. Despite the innovative thinking and technical ingenuity behind its design, it simply didn't offer the leap in performance needed to warrant mass production. The Bf-109 continued to receive upgrades, while the focus shifted increasingly toward jet-powered designs like the Me-62 and emergency fighters such as the He-16. In the end, only a handful of Me-309 prototypes were built, and none entered operational service. The aircraft never fired a shot in combat, nor did it appear on any front lines. It became another case of ambitious wartime design overtaken by both technological advancement and the brutal realities of war. Yet the Me-309 story is far from a simple failure. It represented a significant step in Germany's attempts to modernize its air force. Its innovative features, particularly the tricycle landing gear and streamlined design, would influence future aircraft. As we will see in the next parts of this exploration, the lessons learned from the Me-309 would feed into other projects, both German and Allied. Though the aircraft never had its moment in the skies, its shadow extended far beyond its short development life. After the disappointing flight test of the Me-309 V1 prototype in 1942, Messerschmitt engineers found themselves in a precarious position. The RLM had placed its hopes on a next-generation fighter, yet what had been delivered failed to meet expectations. Nonetheless, the team behind the Me-309 did not give up. Rather than abandoning the project outright, Messerschmitt pursued a series of design improvements in an effort to rescue the concept and perhaps transform it into a competitive combat aircraft. The first series of modifications focused on the aircraft's undercarriage. The tricycle landing gear had promised better ground visibility and handling during taxiing, takeoff, and landing. It also was thought to be a necessary step toward more modern fighter configurations. However, the system had proven problematic. The nose wheel, in particular, was prone to failure and was sensitive to uneven terrain or rough landings. These issues not only compromised the Me-309's reputation with Luftwaffe test pilots, but also made the aircraft riskier to operate from frontline airfields, many of which were far from ideal. To address this, engineers redesigned components of the gear assembly. The wheel struts were reinforced, and modifications were made to the shock absorbers. Additional changes were implemented to reduce nose wheel vibration during high-speed taxiing. While these adjustments improved reliability slightly, they introduced more weight and mechanical complexity to factors that Germany could ill afford as war production constraints worsened. Meanwhile, flight instability remained a concern. Pilots reported that the Me-309 felt sluggish in turns and occasionally unstable at high speeds. To fix this, aerodynamic revisions were proposed. One such change involved altering the tailplane size and shape. Another idea was to adjust the sweep angle of the wings. Although tests were carried out with varying wing configurations, none produced a dramatic increase in performance. The core issue, however, was that the Me-309 simply did not surpass the Bf-109G in any meaningful way. The Bf-109G, nicknamed the Gustav, was faster in some altitude bands, easier to maintain in the field, and already in mass production. It was equipped with the powerful DB605 engine, the same engine initially intended for the Me-309. In side-by-side comparisons, the older model often performed better despite being nearly 5 years older in concept. The Luftwaffe Command began asking hard questions. Why replace a reliable aircraft with one that is no better and possibly worse. The engineers knew that to justify continuing, they had to deliver something transformative. In response, the Messerschmitt team began exploring more radical modifications. One of the more ambitious variants proposed was a heavy fighter bomber version of the Me 309, which would carry additional fuel and bombs under the wings. This configuration, however, placed even more strain on the already delicate airframe and further reduced speed and maneuverability. In addition, other experimental proposals emerged, including installing a pressurized cockpit and improving the cooling system. However, Germany's material shortages, combined with the growing number of competing aircraft programs, meant that very little of these ideas could be practically implemented. Each improvement required new tools, new materials, or more time luxuries that were increasingly rare by mid-1943. While all this was happening, the skies over Germany were changing rapidly. The Allied bombing campaign was intensifying, and the Luftwaffe was now being forced into a defensive posture. Fighters were desperately needed to protect industrial centers, oil refineries, and transportation infrastructure from day and night. Attacks, speed of production, and proven combat performance became the only two things that mattered. As the Me 309 continued to underwhelm, another aircraft was capturing attention, the Me 262. The Me 260 jet fighter, though plagued by its own development challenges, represented the future of air combat. With speeds exceeding 800 kilometers per hour, it had the potential to outfly anything the Allies had in service. The RLM quickly shifted priorities, allocating critical resources to the Me 260 project. Meanwhile, emergency programs like the Focke-Wulf Ta 152 and the Heinkel He 160 also began to crowd the landscape. Within this context, the Me 309 appeared increasingly obsolete. It was neither the stopgap solution the Luftwaffe needed nor the revolutionary leap that would turn the tide in the skies. Still, several prototypes continued flying under limited testing protocols. The Me 309 V2, V3, and V4 each introduced different configurations. Some carried upgraded armament setups, like the MG 150-120's cannons in the wings or a 30mm Mk 108 cannon mounted in the nose. Others tested alternative cooling systems, including an angular radiator system similar to that used in the Focke-Wulf Fu-190D. These variants yielded useful technical data, but again, none produced results dramatic enough to reverse the project's decline. One of the most interesting aspects of the Me 309's story is how much the aircraft influenced later designs, even indirectly. The tricycle landing gear configuration, although problematic in the Me 309, would later be used successfully in the Me 262 and became standard in post-war aircraft designs. Similarly, the idea of a pressurized cockpit, still novel in the early 1940s, would become a key requirement in late war and Cold War era aircraft. Engineers also benefited from the research into high-speed aerodynamics and wing-loading behavior gained through the Me 309 program. The lessons learned were not wasted, even if the aircraft itself never entered service. By late 1943, the Me 309 was unofficially canceled. No formal announcement was made, but the RLM had stopped allocating funding and materials. The few remaining prototypes were either stored or used for limited training and research flights. No production line was ever established. In retrospect, the Me 309's failure is understandable not because it was a poorly conceived aircraft, but because it was the right idea at the wrong time. The Messerschmitt team had tried to build a modern fighter with advanced features, but they had underestimated how quickly the war and aviation technology would evolve. What looked promising in 1940 was already marginal in 1942 and irrelevant by 1944. The design philosophy that had once made the Bf 109A legend was no longer enough. Moreover, the political and logistical pressures of wartime Germany made it nearly impossible for any new piston-engine aircraft to receive a fair chance. Jet propulsion was now the future, and the Luftwaffe, desperate to reverse its losses, placed all its remaining hopes on technological breakthroughs. Yet it is important to acknowledge the skill and ambition of the Me 309's designers. They worked under incredible pressure, with limited resources, and amidst growing chaos. They tried to modernize German air power with every tool available to them. Even as the strategic situation deteriorated rapidly, the Me 309 project, in the end, became a victim of circumstance, a tale not just of an aircraft, but of a moment in history when time itself was the greatest enemy. By early 1944, the Luftwaffe's priorities had shifted decisively. Germany was now under near constant aerial bombardment, and the pressure to field effective interceptor aircraft had reached a critical level. Advanced designs were being pushed into service rapidly, regardless of whether they were fully tested. Amid this urgency, the Me 309 project quietly faded into obscurity, but before it vanished completely, it left behind a legacy of lessons, some subtle, some significant, that would influence not only German aviation, but post-war development globally. One of the more overlooked aspects of the Me 309 story was the internal struggle within Messerschmitt itself. By the midpoint of the war, the Messerschmitt Design Bureau was overwhelmed. They were simultaneously managing the ongoing production and development of the Bf 109 series, refining and testing the Me 160 jet fighter, collaborating on the Me 210 and 410 heavy fighters, and supporting emergency projects like the Me 163 Comet rocket interceptor. The company's resources, both human and material, were stretched dangerously thin. The Me 309 team had to fight for attention, funding, and materials, often working in the shadow of more immediate and promising aircraft. This meant that improvements and solutions came slowly. Worse, every delay increased the perception within the Reichsluftfahrtdienst (RLM) that the Me 309 was a flawed project. In wartime, perception can be just as decisive as performance. Still, the engineering team pressed on with alternate proposals. A notable one was the Me 309B, a variant planned to include a high-altitude optimized engine and larger fuel tanks to extend range and loiter time for bomber interception missions. The idea was to create a capable long-range interceptor to challenge heavy Allied bombers, such as the B-17 Flying Fortress and the Lancaster. However, the increased weight from extra fuel and armament only worsened performance metrics that were already below expectations. A second proposed variant, Me 309Z, imagined a twin fuselage version of the aircraft, somewhat similar in concept to the American P-82 twin Mustang. This radical design attempted to double the firepower and possibly increase range, but it never left the drawing board. These proposals reflect a broader desperation within the Luftwaffe during this phase of the war, where innovation sometimes drifted into impractical or overly ambitious territory. Due to the increasingly dire situation, despite the setbacks, the Me 309 continued to fly in prototype form. A few of these aircraft were used to test avionics systems and gun calibration for future fighters. Data collected from these flights contributed to the broader knowledge base of German aviation engineering. In particular, one area of valuable research was cockpit pressurization and pilot environment control at high altitude, though the Me 309 never reached operational levels. Its test flights helped engineers understand how to design better pilot conditions for future models, including the Ta-152 and jet-powered aircraft. Another technical domain that benefited from the Me 309 project was weapons integration. Engineers had experimented with mounting combinations of 13mm MG-130 machine guns and 20mm MG-150 1/20th cannons in the nose and wings. Some prototypes also explored the use of the 30mm Mk-108 cannon, which would later become a devastating anti-bomber weapon. However, integrating these weapons into the narrow nose space of a sleek fighter presented real challenges. In terms of balance, recoil absorption, and cooling, the experience gained here would later inform design choices on other German fighters, particularly when it came to nose-mounted weaponry on the Me-62 and even some experimental aircraft. One feature that repeatedly drew attention during testing was the aircraft's landing performance. The tricycle landing gear, while offering better forward visibility and modern takeoff angles, still had occasional issues with mechanical failures during hard landings. The system's hydraulics were prone to leaking, and the nose wheel was sensitive to alignment under stress. While these problems were gradually being addressed, they never fully went away before the program ended. By this point, the Luftwaffe was adopting a policy of only backing aircraft that were either already in production or had already proven vastly superior in performance, with the Focke-Wulf FW-190D and Ha-150 models providing excellent performance, and the Me-160 finally entering combat service in limited numbers. The Me 309 seemed increasingly unnecessary. Even the upgraded Bf 109K, a further refinement of the original design, was outperforming the Me-309 in many respects and could be produced with existing facilities and tooling. Another factor contributing to the project's demise was the escalating pressure from the Allied bombing campaign. Factories were being hit, supply chains disrupted, and resources like aluminum, rubber, and fuel became harder to acquire. Aircraft programs that could not demonstrate immediate battlefield results were quickly removed from priority lists. In that environment, the Me-309 had no chance of reaching full production. Despite all this, the Me-309's development offered important strategic insights to Germany's aviation planners. For one, it served as a clear lesson that starting over from scratch, even with good intentions, was often less effective than improving proven designs. The Me-309 had tried to leap ahead, but it lacked the refinement that incremental development can bring. In contrast, the Bf-109, which had seen years of small, continuous upgrades, still held its own in combat by 1944. Moreover, the Me-309 highlighted the limits of attempting to field advanced technologies during wartime conditions. Features like pressurized cockpits and tricycle landing gear were valuable, but only if they could be reliably produced, serviced, and supported in the field. In a civilian or peacetime context, these innovations might have flourished, but in the midst of a massive war, where airfields were bombed, resources were limited, and time was short, such features sometimes became liabilities. At the same time, the project hinted at what could have been if it had started earlier, or if Germany had a more streamlined aircraft development process. Had the Me-309 received full backing in 1940 or early 1941, it might have matured in time to be useful during the critical air battles over Europe and the Eastern Front, but development delays, shifting priorities, and the increasingly chaotic war effort conspired to ensure that it remained stuck in the prototype phase. By mid-1944, the remaining prototypes were either scrapped or reassigned for non-combat roles. Some were reportedly stored at test centers, such as Recklen or Oberpfaffenhofen, where they were occasionally used for experimental trials or as training aids for maintenance crews. No further variants were constructed, and by the time the war ended in 1945, the Me-309 had become little more than a footnote in German aviation history. Still, it is a footnote worth remembering. The Me-309 represents both the ambition and the limitations of wartime innovation. It was a forward-looking aircraft designed by capable engineers, hindered by a lack of time, shifting strategic needs, and the harsh realities of an industrial system under siege. Its failure was not due to incompetence or poor ideas, but because it was conceived at a time when Germany could no longer afford patience. In the next part of this series, we will explore how the Me-309's legacy survived beyond the war, influencing aircraft design in the post-war era and even shaping decisions made by the victorious Allies as they examined the aircraft and captured documents and test reports. As the war in Europe drew closer to its end in 1945, many of Nazi Germany's most ambitious aviation projects were either terminated or seized by Allied forces. Among the numerous blueprints, test aircraft, and factory remnants scattered across the crumbling Third Reich were the prototypes and technical files related to the Messerschmitt Me 309. Though it had never been accepted into combat service, the aircraft did not simply vanish into history. Instead, it contributed quietly but meaningfully to the development of post-war aviation, both inside and outside Germany. With the collapse of Germany in May 1945, the Allied powers quickly began a massive effort to collect as much of the Reich's military and technological data as possible. This effort, known under operations such as Operation Lusty Luftwaffe Secret Technology and Operation Paperclip, aimed to extract value from the advanced research Germany had conducted during the war, particularly in aviation, rocketry, and jet propulsion. American, British, and Soviet forces each captured Messerschmitt facilities and flight testing grounds. In the process, they came across Me-309 documents, prototypes, and test results. Though the aircraft itself had not been revolutionary in combat terms, the ideas embedded in its design were of great interest to post-war engineers. One of the first aspects studied was the aircraft's tricycle landing gear, which, although problematic in its early application, was ahead of its time compared to the tailragger designs that still dominated both axes and Allied aircraft during the war. Engineers on both sides recognized that tricycle gear allowed for safer takeoffs and landings, improved forward visibility, and could better accommodate higher takeoff weights important for the next generation of fighters and jet aircraft. Post-war, fighter designs, such as the American F-86 Sabre and the Soviet MiG-15, would incorporate tricycle landing gear as standard, while the Me-309 wasn't their direct influence. Its data supported the broader consensus that the tricycle configuration was the future of aviation. The pressurized cockpit concept tested in the Me-309 also caught the attention of Allied engineers. While pressurized flight cabins had already been studied before the war, the German data on sealing, structural reinforcement, and high-altitude pilot conditions added further insight to existing research. This would prove useful not just in military aircraft, but also in the rapidly developing field of civilian jetliners that would emerge in the 1950s and 1960s. Further, the Me-309's armament configurations and gun placement experiments were studied carefully. Post-war combat aircraft would increasingly shift toward centralizing weapons in the nose, or integrating them within the wings, depending on the specific mission profile. The engineering behind fitting a 30mm cannon and multiple machine guns into a narrow airframe was a technical challenge that was closely analyzed in Allied studies. The aircraft's aerodynamic layout, although not groundbreaking, had also incorporated several advanced ideas such as smooth skin finishes for improved laminar flow and refined fuselage shapes for drag reduction. These elements mirrored work being done in the United States and Britain, especially in high-speed flight research programs. The Me-309's aerodynamic documentation helped validate certain theoretical models that were then being tested in wind tunnels across Allied laboratories. But beyond the technical data, the Me-309 story also served as a case study in failed wartime innovation. For aviation planners and engineers studying Germany's wartime programs, the Me-309 was a cautionary tale about the risks of overcommitting to new designs during periods of operational stress. In the U.S., the Army Air Forces reviewed the Me-309 as part of a larger inquiry into how the Luftwaffe had structured its aircraft development priorities and why so many promising designs had failed to make a difference on the battlefield. They found that Germany's aviation industry had suffered from several key issues: overlapping projects, too many designs were pursued simultaneously, leading to competition for resources and engineering personnel, shifting political priorities. Aircraft projects were sometimes promoted or abandoned based on personal influence rather than objective performance. Production inconsistency: promising aircraft could not reach full-scale production due to material shortages, bombings, or labor problems. The Me-309 was one of many German aircraft that fell into this pattern. Innovative, on paper, technically impressive, but ultimately too late or too troubled to make an impact. This insight influenced how Allied nations structured their own aviation research and procurement strategies in the early Cold War period, emphasizing fewer, more carefully managed programs with clearer goals and deadlines. Meanwhile, in the Soviet Union, captured Me-309 documents and components were sent to aviation institutes in Moscow and beyond. Soviet engineers, already working on next-generation jet fighters, were particularly interested in the Me-309's undercarriage, structural materials, and wing profile. The Soviets were known for absorbing lessons quickly from foreign designs, often using them as inspiration for their own innovations. While there's no direct evidence that the Me-309 influenced specific Soviet models, its technical contributions likely fed into the broader knowledge pool that shaped aircraft like the MiG-9 and MiG-15. Back in Germany, now divided between East and West, the legacy of the Me-309 was more philosophical than practical. In West Germany, post-war aviation was initially banned, but when it resumed in the 1950s, many of the engineers who had once worked on wartime designs, including those at Messerschmitt, returned to civilian and military aerospace work. The lessons they had learned, including the successes and failures of projects like the Me-309, became part of a larger effort to modernize German aerospace industries within the NATO framework. Messerschmitt itself, after a period of post-war dormancy, re-emerged and took part in several important aviation projects, including the development of the Hispano HA-00 jet trainer and work on the Panavia Tornado multi-role fighter in later decades. Though the Me-309 had disappeared, the minds behind it continued to shape the aviation world. Interestingly, some aviation historians have drawn parallels between the Me-309 and post-war aircraft like the French Dassault Ouragan, and even early U.S. jet fighters, not in terms of performance, but in their transitional design philosophy. The Me-309 had tried to bridge the gap between classic piston engine fighters and the emerging jet age. That challenge how to move from one technological era to another is one that every aviation power would face again and again during the second half of the 20th century. In museums today, the Me-309 is almost entirely absent. No complete airframe survived the war. A few small parts, photographs, and engineering drawings are all that remain. Yet its shadow lingers in the corridors of aviation history, not because it fought in the skies, but because it represented a turning point in design thinking. What might have happened if the Me-309 had been developed sooner? That question has fascinated aviation enthusiasts for decades. Had the prototype flown in 1941 rather than 1942, the aircraft might have had enough time to mature, be refined, and enter service by 1943. It could have served as a more modern complement to the BF-109 and perhaps even influenced the development of the Me-260 to more directly. But history is not shaped by what-ifs, only by what actually occurred. And what occurred was this: the Me-309, despite great potential and thoughtful design, arrived late, was burdened by technical challenges, and was eclipsed by faster, more revolutionary projects like the Me-262. In the end, the project was discontinued not with a dramatic cancellation, but with quiet abandonment as the Luftwaffe turned to other desperate solutions. In our final part, we'll explore a full retrospective on the Me-309's significance, what it represented to German engineers, what it taught the world about military aviation development, and why, in spite of its failure, it remains a symbol of ambition in a time of total war. The Messerschmitt Me-309, though never mass-produced or flown in combat, remains an important chapter in the history of military aviation. It serves as a powerful example of both ambition and limitation in aircraft development during the most intense period of technological advancement the world had ever seen. As we reflect on its legacy, we must understand it not merely as a failed prototype, but as a symbol of transition bridging the classical fighter designs of the 1930s with the advanced, high-performance aircraft that would define the second half of the 20th century. In the end, the Me-309 was more than a collection of aluminum and steel. It was an embodiment of German aviation philosophy during a time of escalating war. At its heart, the Me-309 project was an attempt to think ahead, to prepare for a future battlefield in the skies that demanded more speed, more firepower, more survivability, and more sophistication. Messerschmitt's engineers were not short on vision. The aircraft was intended to break from past conventions and embrace a forward-looking design language, including features like a tricycle landing gear, improved aerodynamics, a pressurized cockpit, and heavier firepower integration. But what separated vision from success in World War II was not just engineering, it was timing, logistics, and adaptability to changing wartime needs. And it was here that the Me-309 faltered. By the time the Me-309 prototype flew in 1942, Germany's strategic position had already started to shift. The Soviet counteroffensive in the east, the growing strength of Allied air power, and the opening of new fronts meant that Germany could no longer afford lengthy development cycles. Aircraft had to be not just promising, but immediately effective. Every week mattered. The Me-309 needed time for testing, for modifications, for evaluation in multiple roles, but it didn't get that time. The Luftwaffe still had confidence in the Bf-109, especially its later G and K variants, which could be built in existing factories and flown by experienced crews already familiar with the platform. The risk of transitioning to a new fighter, even a more advanced one, seemed a great deal. Moreover, Germany's aviation priorities were becoming increasingly centered on jet propulsion. The Me-262 was promising speeds that were nearly double those of piston-powered fighters. Though its development was slow and politically complicated, it eventually consumed much of the attention and resources once available to piston engine projects. Like the Me-309, then there were production concerns. Material shortages, aluminum, rubber, copper, and especially fuel meant that only the most vital programs could proceed. Aircraft that could be quickly built and serviced in the field had the advantage. The Me-309, being new, required new tooling, new training, and a new supply chain. It was simply too much, too late. The Me-309 in historical context placed the Me-309 in proper historical perspective. It's helpful to compare it to several aircraft of its era. Consider the Supermarine Spitfire, the American P-51 Mustang, and the Soviet Yak-3. All of these fighters were designed before the war or in its early stages, and each one went through numerous iterative upgrades based on combat feedback. Their strength was not that they were perfect at launch, but that they were adaptable, well supported, and improved over time. The Me-309, in contrast, had no time to evolve. It faced opposition not from enemy aircraft, but from the realities of industrial warfare, production crises, and shifting priorities. Still, its core concepts, especially in aerodynamics and pilot-centered design, reflected an understanding of what future air combat would require. One can imagine a parallel world where the Me-309, introduced earlier and with better timing, might have become the Luftwaffe's new backbone. With refinement, it may have been a faster, more stable replacement for the Bf-109, capable of competing with the Spitfire Mk9 or the early Mustangs. But even in this imagined scenario, it's unlikely the Me-309 could have reversed the course of the air war. By 1944, the Allies had overwhelming advantages not only in aircraft numbers, but also in pilot training, fuel supply, and radar-supported coordination. Lessons learned from the Me-309 from a modern aviation standpoint. The story of the Me-309 provides valuable lessons that go beyond its design. Timing is critical. A technically good design means little if it arrives too late. Speed of development and implementation is as important as the innovation itself. Incremental versus radical change, sometimes upgrading a proven design, like the Bf-109, can yield better results than starting from scratch. The balance between innovation and reliability must be managed carefully. Production readiness matters. An aircraft's performance on paper or in prototype trials is only part of the equation. Ease of production, availability of parts, and maintenance requirements can make or break a combat aircraft program. Technological transitions are disruptive. The Me-309 was caught in the shift from piston engine to jet engine aircraft. This transition created uncertainty, diverted resources, and made it harder for late-stage piston fighters to gain traction. The value of experimental projects, even if a project fails to reach production, it can still offer significant knowledge. The Me-309's testing contributed data on tricycle gear, cockpit pressurization, and structural design that informed later projects. The human element, it's important to remember that the Me-309 was not just a machine, it was the product of human effort. Engineers, mechanics, test pilots, draftsmen, and factory workers all contributed to its creation. Many of them had worked on earlier Messerschmitt designs and brought with them a deep knowledge of flight dynamics, stress testing, and battlefield needs. The Me-309 represents their continued effort to push the boundaries of what was possible, even under extraordinary pressure. Some of these same individuals would go on to have post-war careers in aviation, both in East and West Germany, and even in allied countries. Their experience with projects like the Me-309 gave them a unique perspective on aircraft development, helping to shape aerospace advancements in the decades to come. A fighter without a war. Ultimately, the Me-309 is remembered as a fighter without a war. It never reached the front lines, never dogfought over the skies of Europe, and never influenced a single battle. Yet its significance lies in what it tried to be, a bridge between eras, a signal that the Luftwaffe and German aviation more broadly understood the need for a leap forward. But in war, understanding is not always enough. The skies of World War II were dominated not by potential, but by execution. The aircraft that won battles were those that could be built quickly, flown reliably, and adapted rapidly. The Me-309 had promise, but promise is not a weapon today. The Me-309 stands as a reminder of what could have been. It is studied by aviation historians and enthusiasts as one of the Luftwaffe's many lost opportunities, designs that, in different circumstances, might have had more influence. But more importantly, it's a reminder that even in the most intense periods of technological race, not every idea can succeed, and that's not a failure, it's the nature of progress. In the fierce crucible of World War II, the Me-309 was a spark, one of many. It flickered, it glowed, and then it faded. But it helped light the path forward in ways we still trace today in the sleek lines of modern fighters, the safety of landing gear, and the comfort of high-altitude cockpits. Though it never roared into battle, the Me-309 remains in its own quiet way, part of the story of flight.